Hello, my name is Yashodhan Joshi with Bentley's technical support team. Joining me is Karthik Sundaresan, Senior Consultant of the Water Infrastructure Group. In this video series, we are attempting to address some of the common issues in modeling a water supply network, which will be covered in subsequent videos. The idea of this video series is to address common issues in building and running your water distribution network and provide a basic understanding of setting up and working on your models. We are also going to cover some familiarity with basic tools and its functionality through this video series and provide a quick and easy approach to modeling. The workflow is generalized to a sample model, and we have attempted to keep things as simple as possible for the ease of learning. With this, let us move to part 1 of this video series, in which we discuss geo-referenced data. So before we start working on our WaterGEMS model, let us take a look at what information we have to build our network. So this is the drawing that we have received for the sample project. Okay, so as you can see, this is a simple road network that we have, and we are supposed to lay the water supply pipeline along the road alignment. That is why this map is available with us. uh, we have also the location of a potential source over here, and they have given the information of the HGL at that source, that is 610 meters. Okay, so this is the prevailing level uh, through which we'll be supplying the water to this area. And other than that, we have the contours, that is the ground level information of this entire area. This is the contour data that I have with me, and this is the road network which I have extracted from this road layout. Okay, so this can be our pipe network, okay, along which we'll be laying our pipes. So this is the pretty basic information that we are currently having of our network, and we'll use this information to build our model in WaterGEMS. I'll be showing that, and assign the demands accordingly. Okay, so one thing which we can understand from here is that most of the times you will be getting data which is not geo-referenced, like this is. This is like a simple drawing over here, and the data that you might need is the contour data or the elevation data to be used to assign the elevations to your junctions, which will be produced at these pipe endpoints. And there is no problem with this, but this may not be georeference data, and your contour data might be georeference data depending on how you have done the topographical survey. So the thing to ensure here is that if you are having contour data, make sure that it is aligning properly with your model, and you are able to actually get the elevation data imported into your WaterGEMS model. So we'll demonstrate this in the WaterGEMS model when we are building it. Okay, so let us move to WaterGEMS now. Okay, so this is just a simple new project that I've opened up, and this is what most of you would see when you first open WaterGEMS. A couple of things to first look at is the unit system you are going to work in. So the sample project that I have with me here is in SI system, that is System International, and I would like to work in that system. So the first thing I'll do is I'll go to Tools, More, and Options, and click on this Units tab and check the unit system that is set by default over here. So you can see that it is set to US customary, and we are not going to work in this unit system which has uh, different units for all the parameters. So I'll just go ahead and select SI from the drop down menu, but the units are not changed here as well. So you have to go to reset defaults and set the default system as SI. Once you click OK, the unit system will be successfully changed. And the benefit of this is that next time you are working on a project, it will be always set to the SI system. So in case you are working on projects that are more or less in the SI system, this will be a benefit on those cases. In those cases, so once we have set up the unit system. Let us now bring in our road network. So the way to do that is by using the model builder tool that is available again under the tools bar. So let us go to the model builder tool. We'll click on new. Okay, now here it is asking me what is the data source type. So I have the CAD files like I showed you over here. These are all drawing files that we typically receive for such projects. So if you have a drawing file, you can export it to DXF to get a DXF format file. Okay, the command is right here in in AutoCAD. So if you want, okay, so this is the line network that we are going to use. So if you want, you can just type in DXF out. Okay, you can see here, and it will ask where to save this network. So I've already saved a couple of files over here, so I'll just rewrite the existing one with as road network DXF. So basically this is the file format that model builder is going to recognize to build your network. So here select CAD files as the data source type and click on browse. Okay, and go to the folder data and road network. Okay, once you bring it in here, you can see this 0 polyline. So it has identified that the uh, data type is of polyline type. Okay, just click next. Specify the coordinates units. So we are working in the SI system, so it will be meters. Always check this establish connectivity using spatial data. So what happens is that it will create nodes if there are you know no nodes at the endpoint, and this will also help in that. So just clicking next. We'll keep these as the default options. Okay, so these are basically to add the data. If you want to remove some data from existing data that is present in the model, that is also possible. And if you want to just update existing data without physically adding it, that is also an option over here. And we just want to add the data right now, so we'll keep everything as it is. and just move ahead. Next, we'll be importing the data into the current scenario, and we are mapping the elements by label. Okay, we'll again move next, and the key field over here will be label. So this is the way the pipes will be mapped. Okay, we don't have a lot of information to assign over here, so all these fields, thickness, handle, line type, line width, and all these are graphical entities from CAD, and these are not hydraulic parameters, so we will leave everything as it is. We just click next. Okay, for snapshot settings, this is a feature in ModelBuilder which allows you to take a snapshot between importing data. If you are doing it multiple times, then this will help you keep track between what you imported sometime before. So would you like to build a model now? Yes, and this will create selection sets for the model. Okay, click on finish, and yes, so we have a couple of messages here that 39 nodes were created at pipe endpoints, 26 pipes were created, and there was a selection set created of all the elements. Okay, we also have messages that no start node found, within the tolerance, and created default start node. So these are basically information and warning messages that the whatever the software has done to build the model. So we'll just close this off, and synchronizing the drawing will add, remove, and update elements. So yes, we want to add them, and we'll just click yes. Okay, so if you don't see anything, don't panic, just click on this zoom extends button, and the network will be available here.